Solving systems of linear equations in three variables. Finding quadratic functions. Definition. A linear equation in three variables is an equation that can be put into the form ax plus by plus cz equals d, where a, b, c, and d are constants, and a, b, and c are not all zero. Linear equation in three variables. An ordered triple (xyz) represents values of x, y, and z, just as an ordered pair (xy) represents x and y. An ordered triple ABC is a solution of an equation in terms of x, y, and z if the equation becomes a true statement when a, b, and c are substituted for x, y, and z respectively. A system of linear equations in three variables consists of two or more linear equations in three variables. The solution of a system of linear equations in three variables is an ordered triple that satisfies all of the equations. Solving a system of three linear equations in three variables. To solve a system of three linear equations in three variables, 1. Select a pair of equations and eliminate a variable. 2. Select any other pair of equations and eliminate the same variable as in step 1. 3. The equations you found in steps 1 and 2 form a system of linear equations in two variables. Use elimination or substitution to solve this system. 4. Substitute the values of the two variables you found in step 3 into one of the original equations that contains the third variable. Solve for the third variable. 5. Write your solution as an ordered triple. Solving a system of three linear equations in three variables. When you have three variables x, y, and z, your solution is in three dimensions, like this point 3, negative 3, 1, where 3 is my x, negative 3 is my y, and 1 is my z. In this example, solve the system x plus 4y plus 2z equals 3, 2x minus 3y plus 5z equals negative 7, 3x plus 5y minus 4z equals 22. We'll refer to the top equation as equation A, the middle one is equation B, and the bottom one is equation C. The first step is to decide which variable we should eliminate. X will be the easiest to eliminate because equation A has a 1x, equation B has a 2x, and equation C has a 3x. So for my first step, I want to take equation A and multiply it by negative 2 so that when I add it to equation B, my x's will be eliminated. So I have negative 2x plus negative 8y plus negative 4z equals negative 6. And I'm going to add to that 2x minus 3y plus 5z equals negative 7. When I add that, my x's cancel. Negative 8y minus 3y is negative 11y. Negative 4z plus 5z is 1z. And negative 6 plus negative 7 is negative 13. So we'll call this one equation D. So my second step is to multiply equation A by negative 3 so that when I add it to equation C, my x's cancel. So I have negative 3x plus negative 12y plus negative 6z equals negative 9. and I want to add to that 3x plus 5y minus 4z equals 22. When I add that together, the x's cancel. Negative 12y plus 5y is negative 7y. Negative 6z minus 4z is negative 10z equals negative 9 plus 22 is 13. And we'll call this one equation E. Our third step will be to take equation D and E and try to eliminate either y or z. For my next step, looking at equations D and E, if I take equation D and multiply it by 10, I would be able to eliminate the z's. So I have negative 110y plus 10z equals negative 130, and I'm going to add that to negative 7y plus negative 10z equals 13. And negative 110y plus negative 7y is negative 117y. Our z's cancel, so that equals negative 130 plus 13 gives me negative 117. Dividing both sides by negative 117, y equals 1. Now that we've found our y, we can go back to either equation D or E and find z. So for step 4, I'm going to use equation D and replace my y with 1. So I have negative 11 times 1 plus z equals negative 13. My next step is negative 11 plus z equals negative 13. Add 11 to both sides, and z equals negative 2. So for my last step, I want to choose either A, B, or C, substitute in my z and my y to find x. I'm going to choose equation A. So I have x plus 4 times 1 plus 2 times negative 2 equals 3. Then I have x plus 4 plus negative 4 equals 3, which means x equals 3. So my answer is 3, 1, and negative 2. I can check my answer by substituting into the original equation. So for my first equation, I have x plus 4y plus 2z equals 3. X is 3 plus 4 times y, which is 1, plus 2 times z, which is negative 2. Enter, and we get 3, which is what we should have. Our second equation, 2x minus 3y plus 5z equals negative 7. 2 times x, which is 3, minus 3 times y, which is 1, plus 5 times z, which is negative 2, should equal negative 7. For the last equation, 3x plus 5y minus 4z equals 22. 3 times x, which is 3, plus 5 times y, which is 1, minus 4 times z, which is negative 2. And that should equal 22. So my order triple of 3, 1, negative 2 is the correct solution for this system of equations. In this example, solve the system 4x plus y plus 3z equals 9, 3x minus y minus 2z equals 4, negative 2x plus 2y minus 6z equals 10. Looking at my x, y, and z, I need to choose one of the variables to eliminate. If I wanted, I could always eliminate z, then y, have an x, substitute to find y, then substitute to find z. Looking at the numbers in front of x and y and z, it's going to be easiest to eliminate the y's first. My first step is going to be to add a and b. So I have 4x plus y plus 3z equals 9. 3x minus y minus 2z equals 4. 4x plus 3x is 7x. Y minus y is 0. 3z minus 2z is 1z. And 9 plus 4 is 13. So we'll call this one equation D. For step 2, if I take equation A and multiply it by 2, if I take equation B and multiply that by 2, when I add it to equation C, the y should eliminate. So 2 times 3 is 6x. Negative y times 2 is negative 2y. Negative 2z times 2 is negative 4z. And 4 times 2 is 8. Equation C is negative 2x plus 2y minus 6z equals 10. When I add those, 6x minus 2x is 4x. Negative 2y plus 2y is 0. Negative 4z minus 6z is negative 10z equals 8 plus 10, which is 18. And we'll call this one equation E. Looking at equations D and E, it's going to be easier to eliminate the z than eliminate the x. If I take equation D and solve it for z, z would equal 13 minus 7x. I could substitute that into equation E, which would give me 4x minus 10 times 13 minus 7x, close parentheses, equals 18. Distributing my negative 10, I bring down my 4x, and I have negative 130 plus 70x equals 18. Adding like terms, I have 74x minus 130 equals 18. Adding 130 to each side, 74x equals 148. Dividing both sides by 74, x equals 2. So for step 4, I'm going to substitute x into my equation for D. I'm going to use my one solve for z. So when I substitute, z equals 13 minus 7 times 2, which is 13 minus 14, which is negative 1. So z is negative 1. Then I'm going to use equation A to find y. 4 times 2 plus y plus 3 times negative 1 equals 9. 8 plus y plus negative 3 equals 9. Y plus 5 equals 9. So y equals 4. So my ordered triple is 2, 4, negative 1. Now I want to check my work. We want to substitute into each of the equations. My first equation is 4x plus y plus 3z equals 9. 4 times x, which is 2, plus y, which is 4, plus 3 times z, which is negative 1, should equal 9. Now for our second equation, 3x minus y minus 2z equals 4. 3 times x, which is 2, minus y, which is 4, minus 2 times z, which is negative 1. Enter, and it equals 4. For our third equation, negative 2x plus 2y minus 6z equals 10. Negative 2 times x, which is 2, plus 2 times y, which is 4, minus 6 times z, which is negative 1, and that should equal 10. So this ordered triple does work for our system of equations. In this example, solve the system 2x plus 3z equals 6, 2y minus z equals negative 2, and 4x minus y equals negative 13. So the first step is to decide which variable we should eliminate. Looking at the y and the z, either of those would be easy to get rid of. If we got rid of the z, we'd have to multiply equation A by nothing and equation B by negative 3 so that the z's would cancel. So I have 2x plus 3z equals 6, and then multiplying by 3. 2y times 3 is 6y, minus 3 times 1z is 3z, equals 3 times negative 2 is negative 6. I end up with 2x plus 6y equals 0. And that's going to be our equation D. Our next step is to eliminate either x or y. Using equation C and equation D, I can eliminate my y more easily than my x since my y's have different signs. So I'm going to bring down my D equation, 2x plus 6y equals 0, and then multiply equation C by 6. 6 times 4x is 24x minus 6 times y is 6y equals 6 times negative 13 is a negative 78. Adding 2x plus 24x is 26x. The y's cancel. 0 plus negative 78 is a negative 78. Divide both sides by 26. X equals negative 3. I can use equation A, C, or D to find my other variables. Using equation A, I'm going to replace x with negative 3. So I have 2 times negative 3 plus 3z equals 6. 2 times negative 3 is a negative 6, plus 3z equals 6. Add 6 to both sides. 3z equals 12. Divide, and z equals 4. To find y, I can use equation B, equation C, or equation D. Using equation C, I have 4 times x, which is negative 3, minus y equals negative 13. 4 times negative 3 is a negative 12, minus y equals negative 13. Add 12 to both sides. Negative y equals negative 1, so y equals 1. My answer is the ordered triple, negative 3, 1, 4. Using our calculator, we want to check the ordered triple negative 3, 1, 4 with our system of equations. Our first equation is 2x plus 3z equals 6. 2 times x, which is negative 3, plus 3 times z, which is 4, should equal 6. With our second equation, 2y minus z equals negative 2. 2 times y, which is 1, minus z, which is 4, should equal negative 2. Our last equation, 4x minus y equals negative 13. We have 4 times negative 3, which is our x, minus our y, which is 1, and that should equal negative 13. Our ordered triple does work for our system of equations. The intersection of three planes can be one point, a line, a plane, or the empty set. So, the solution set of a system of linear equations in three variables can contain exactly one ordered triple, an infinite number of ordered triples, or no ordered triples, which is the empty set. Equation of parabolas. To find an equation of a parabola that contains three given points, 1. Obtain a system of three linear equations in three variables by substituting the coordinates for each of the three given points into the general equation y equals ax squared plus bx plus c. 2. Solve the system you found in step 1. 3. Substitute the values of a, b, and c you found in step 2 into the equation y equals ax squared plus bx plus c. In this example, find an equation of the parabola that contains the given points 1, 4, 2, 7, and 4, 25. First thing we need to remember is that our equation of a parabola is y equals ax squared plus bx plus c. We're going to have three equations by substituting each ordered pair into the equation of a parabola. So our first step is to take each of our points and substitute into our equation. Starting with 1, 4, y is 4, so 4 equals a times x squared, which is 1 squared, plus b times x, which is 1, plus c. And that will give me a plus b plus c equals 4. Our second point is 2, 7. So instead of y, I'll write 7, and then a times x, which is 2, squared, plus b times x, which is 2, plus c. And that will give us 4a plus 2b plus c equals 7. Our last point is 425. Replacing the y with 25, that equals a times x, which is 4, squared, plus b times x, which is 4, plus c, which gives me 16a plus 4b plus c equals 25. So I have three equations with three unknowns. My first equation, I'll call it A, is a plus b plus c equals 4. My second equation that I'm going to call B is 4a times 2b plus c equals 7. And then my third equation that I'm going to call C is 16a plus 4b plus c equals 25. Now we want to work it the way we've been working the problems in this section, by eliminating a variable, then eliminating a second variable, and solving. It's going to be easiest to eliminate c since they're all 1c. So for step 2, I'm going to take equation A, multiply it by a negative 1, which will give me negative a plus a negative b plus negative c equals negative 4, and I'm going to add to that equation b, which is 4a plus 2b plus c equals 7. When I add that, negative a plus 4a is 3a, negative b plus 2b is a positive b, the c's cancel, and negative 4 plus 7 is 3. So that's going to be our equation D. Then I'm going to use my equation A again, multiplied by the -1. And this time add to that equation C, which is 16A plus 4B plus C equals 25. Negative A plus 16A is 15A. Negative B plus 4B is a positive 3B. The C's cancel, and negative 4 plus 25 is 21. And that's going to be our equation E. Step 4, I need to eliminate either A or B. If I multiply equation D by -3, then the B's will cancel. -3 times 3A is a -9A, plus -3 times B is -3B, equals, and then -3 times 3 is -9. I want to add to that 15A plus 3B equals 21. -9 plus 15A is equal to 6A. The B's cancel, and -9 plus 21 is 12. Divide both sides by 6, and A equals 2. Now I can find B, so I'm going to use my equation D. 3 times A, which is now 2, plus B equals 3. 3 times 2 is 6, plus B equals 3. B equals -3. Now I'm ready to find C. I can use either A, B, or C equations to find that. I'm going to use equation A. So A, which is 2, plus B, which is -3, plus C equals 4. -1 plus C equals 4, so C equals 5. Now that I know my A, my B, and my C, I can write my equation of the parabola. Y equals 2x squared minus 3x plus 5. The equation of the parabola that contains 1, 4, 2, 7, and 425 is y equals 2x squared minus 3x plus 5. We can check this by substituting, or we can check this by graphing the parabola. Going to y equals, if there's anything there, you can clear it out. Type in 2x squared minus 3x plus 5. Zoom, 6 for standard. We can either use our table or trace to verify our ordered pairs. Second and graph will get us to our table. My table shows 1, 4, and 2, 7, and 425. So the 3 points are on this graph. So I have found the correct equation for the parabola containing these 3 points. In this example, find the equation of the parabola that contains the given points: 2, 7, 4, 1, 5, -8. We need to substitute our ordered pairs into our general equation y equals ax squared plus bx plus c. So our first step is to substitute our ordered pairs. Starting with 2, 7, I'm going to replace y with my 7 equals a times x squared, so that's 2 squared, plus b times x, which is 2, plus c. So my result is 4a plus 2b plus c equals 7. My next ordered pair is 4, 1. So replacing y with 1, that equals a times x, which is 4, squared, plus b times x, which is 4, plus c, which gives us 16a plus 4b plus c equals 1. My last ordered pair is 5, -8. So negative 8 for my y equals a times 5, which is x squared, plus b times 5, plus c, which gives us 25a plus 5b plus c equals negative 8. Now I want to use my three equations and eliminate one of the variables. Again, it looks like c is going to be the easiest one to eliminate. So for my second step, I'm going to take equation A, multiply it by negative 1, which gives me negative 4a minus 2b minus c equals negative 7. And then because it has the smallest numbers overall, I'm going to add that to b, then add it to c to try to eliminate my variable c. So I'm going to bring down 16a plus 4b plus c equals 1. Adding those together, negative 4a plus 16a leaves me with 12a. Negative 2b plus 4b gives me a positive 2b. My c's cancel, and negative 7 plus 1 is negative 6. For my next step, I will use negative 4a minus 2b minus c equals negative 7, and this time add it to 25a plus 5b plus c, which equals negative 8. Adding negative 4a plus 25a is 21a. Negative 2b plus 5b is a positive 3b. The c's cancel, and this equals negative 7 plus negative 8, which is negative 15. Considering the numbers in front of A and the numbers in front of B for my equations D and E, it's going to be a little easier to eliminate the B. The least common multiple for 2 and 3 would be 6. If I multiply equation D by a negative 3 and equation B by a 2, I'll have a negative 6b and a positive 6b, which will eliminate. So in my next step, I want to multiply equation D by a negative 3, which will give me a negative 36a plus negative 6b equals 18. Now multiply equation E by 2, and my result is 42a plus 6b equals negative 30. Adding negative 36 plus 42, 6a, my b, cancel out. 18 minus 30 is a negative 12. Dividing both sides by 6, a equals negative 2. Using either D or E, I can easily find B at this point. I'm going to use D, so I have 12a, so 12 times negative 2 plus 2b equals negative 6. 12 times negative 2 is negative 24, plus 2b equals negative 6. Add 24 to both sides, and 2b equals 18. Divide by 2, and b equals 9. So my next step is to find c. I can use either my top equation A, my equation B, or my equation C. Going with equation A, I have 4 times A, so 4 times negative 2, plus 2b, which is 2 times 9, plus c equals 7. Next I have negative 8 plus 18 plus c equals 7. 10 plus c equals 7. C equals negative 3. Now that I have A, B, and C, I can find the equation of my parabola. So substituting into our general equation for a parabola, y equals ax squared, my a is negative 2, plus bx, my b is 9, plus c, and my c is a negative 3. The equation of the parabola that contains the points 2, 7, 4, 1, and 5, negative 8 is y equals negative 2x squared plus 9x minus 3. Again, I can check by either substituting my three ordered pairs into this equation or graphing the parabola to see if the 3 points are on that parabola. So going to my calculator, going to y equals, I need a negative 2x. I have my previous parabola here, so second and delete is my insert, and I can type in my negative, then arrow over. Once you're over the minus sign, change it to a plus. Once you're over the 3, change it to a 9. Arrow until you're over plus again, change that to a minus, and the 5 to a 3. So before we graph, we need negative 2x squared plus 9x minus 3. Graph. We have a choice between using the trace or the table to verify our ordered pairs. I'm going to use table. Second and graph gets us to our table. I have 2, 7 and 4, 1. I also have 5, negative 8. Solving systems of linear equations in 3 variables. When we have 3 equations and 3 unknowns, we can easily find our 3 variables. Finding our ordered triple x, y, and z is the intersection of 3 planes. We can find quadratic functions if we have 3 points that are on the parabola using y equals ax squared plus bx plus c to find a, b, and c, then substitute to find our parabola.